Hello everyone. This side Mayank Jhunjhunwala. Sorry. This side Mayank Jhunjhunwala from IIT Kanpur. So today I'm going to take a session on complex numbers from mathematics. So let's start. So let's start with what complex number basically is. So basically, complex numbers are those numbers which are expressed in the form of iota, where iota is nothing but the root of minus one. So all those numbers which are not real are known as complex numbers. So every complex number is represented by two parts. Every complex number is represented by two parts: a plus ib, a plus iota times b, where a is known as the real part. This is your real part, and b is the imaginary part. This is your imaginary part. Okay, so a is real part and b is imaginary part of your complex number. For example, 2 plus 3 iota. Here 2 is the real part and 3 iota is the imaginary number. Okay, so the complex number is basically the combination of real number and imaginary number. The complex number is in the form of a plus ib, where a is the real number and iota b is your imaginary number. Also, a comma b belongs to real numbers and iota is equal to root of minus 1. Hence, a complex number is a simple representation of addition of two numbers. One is real, another is imaginary. Of part One part of it is purely real, and the part is purely imaginary. Matlab a is purely real and b is purely imaginary. Then we will take the mod of the complex number, so we will get the absolute value. How? Just take under root of square of real part plus square of imaginary part. So let's say z is equal to x plus iy is your complex number, where x is your real part and y is your imaginary part. So root of x square plus y square here. X would be your real part, so x square, and y would be your imaginary part, so y square. So mod z is equal to under root of x square plus y square. Okay. Absolute value of x is represented by modulus, that is mod x, जैसे मैंने बताया. Then this expression is obtained when we apply the Pythagorean theorem in the complex plane. Hence, mod of complex number z is extended from 0 to z, and mod of real numbers x and y is extended from 0 to x and 0 to y, respectively. Now, these values form a right triangle where 0 is the vertex of acute triangle. So, according to Pythagoras theorem, mod z is equal to root of x square plus y square. Basically, आपको ये वाला expression आना चाहिए. ठीक है? Now coming on to addition, simply we can do as just add the real parts and add the imaginary parts, and you will get the new complex number a plus c plus iota times b plus d. Similarly for subtraction, a minus c plus iota times b minus d. For multiplication, what we will do, I will how to multiply two complex number. Let's take an example: 2 plus 3 iota multiplied by 4 minus iota. So how to do it? It's pretty simple. 2 into 4 is 8, then minus 2 iota, then 4 into 3 is 12, so plus 12 iota, and then here iota is multiplied by iota. So you will get iota square. And what is iota? Iota is root of minus 1. Iota is root of minus 1. So from here, when you will do iota square, you will get minus 1. So basically this is minus 1. So this minus and this minus will get plus, and you will get plus 3. So this is how you multiply two complex numbers, and the final answer would be 11 plus 10 iota. 11 plus 10 iota. So in this way you multiply. For dividing, what you will do? For dividing, you will basically multiply the complex number with the conjugate of the denominator. That is a plus ib, a plus iota b upon, sorry, a plus iota b upon c plus iota d. If you want to calculate this thing, then you will multiply it by the complex conjugate of the denominator. So you will get multiplication by c minus iota d upon c minus iota d. So this will become ac plus bd, ac plus bd. Now we will simply multiply the numerator part. You will get ac plus bd plus iota times जो भी मिलेगा आपको ब्रैकेट में. और डिनोमीटर में क्या हो जाएगा? डिनोमीटर में वी हैव बेसिकली डन a plus b a minus b, so it would be a square minus b square, so it would be c square minus iota d square, so it would be plus d square, because iota square is also minus 1, and minus will become plus. So you will get ac plus bd plus iota times something upon c square plus d square. This is your final answer. ठीक है. सो इस तरीके से मैं करता हूँ जब भी मेरे को डिनोमिनेटर से कॉम्प्लेक्स नंबर हटाना है. सो आई विल ऑलवेज मल्टीप्लाई द गिवन नंबर बाय द कॉम्प्लेक्स कॉन्जुगेट. फ्रॉम देयर आई विल रिमूव द आयोटा पार्ट फ्रॉम डिनोमिनेटर. ठीक है. उसके बाद पावर ऑफ आयोटा मैंने बताया. आयोटा इज रूट ऑफ -1. आयोटा इज नथिंग बट रूट ऑफ -1. देन आयोटा स्क्वायर इज 1, -1 सॉरी. आयोटा स्क्वायर इज -1. iota cube, you know, iota cube would be minus iota, because 1 iota multiplied by -1, it would be minus iota. And then iota power 4 would be minus iota into iota, and iota square is -1, so basically this would be 1. So always remember iota power 4 is 1, so always iota power 4k would be equal to 1. And then it will start repeating the cycle. Iota power 4k plus 1 would be root -1. Iota power 4k plus 2 would be -1. Iota power 4k plus 3 would be minus iota. And then iota power 4k again would be 1. So please remember this cycle of iota, that after each 4 multiples, it becomes 1. Okay? Now some identities of complex numbers. Similarly, a plus b square, a square plus b square plus 2ab, a minus b square, a square plus b square minus 2ab, a square minus b square, a plus b minus b, वही वाली सारी प्रॉपर्टीज हैं. a plus b cube, a cube plus 3 a square, b plus 3 a b a b square plus b cube. Similarly, a minus b cube. All those properties which you have already studied in algebraic functions is the same in this complex numbers. Then coming on to some more properties, addition of two complex conjugate numbers will result in a real number. Multi what are complex conjugate numbers? Where I already told you, if one is a plus iota b, if one number is a plus iota b, then its complex conjugate would be a minus iota b. A minus iota b. Okay. So when I will add both these two, then iota part will get cancelled because one is positive and other is negative. So this will cancel with this, and you will get 2a. So addition of two complex conjugate number will result in a real number. Multiplication of two complex conjugate number will also result in a real number. अभी मैंने बताया था यहाँ पे two complex conjugate number का multiplication किया, then I got a real number because iota part was dismissed. Then if x and y are real numbers and x plus iota y is equal to 0, then x is also equal to 0 and y is also equal to 0. मतलब we will equate both real and complex parts to be equal to 0. Then if p, q, r and s are real numbers and if these are equal, मतलब अगर कोई भी दो complex numbers बराबर होंगे, then we can say that real part would be equal to real part and imaginary part would be equal to imaginary part. Cool. Then moving ahead, the complex numbers obeys the commutative law of addition and multiplication. मतलब addition is commutative and multiplication is commutative. Similarly associative भी होता है. Distributive law भी सारे laws इसमें hold करते हैं. Then ये होती है triangle inequality, which I use in triangle also. This is many a times used in questions for complex numbers. So इसको अच्छे से याद कर लेना कि mod of z1 plus z2 is always less than equal to mod of z1 plus mod of z2. Very important triangle inequality used many times, इसको ध्यान रखना, is less than equal to mod of z1 plus mod of z2. ठीक है. Then result of multiplication of two complex numbers and its conjugate value should result in a complex number and should be a positive value. Modulus and conjugate, I already told you, modulus is represented by mod z, where mod will represent root of a square plus b square. Then conjugate of z is denoted by z bar, where z bar is a plus iota b. If z is equal to a plus ib, then z bar would be a minus iota b. Okay. This is also a very important theorem, De Moivre's theorem. De Moivre's theorem statement is what if we will take the power raised n to the some complex number which I have represented in the form of cos x plus iota sin x, where this is the real part and this is the imaginary part, then to the power n of this would be nothing but you just change the arguments to nx. So you will get cos of nx plus iota sin nx. So this is your De Moivre's theorem. Similarly, if you write it in Euler's form, this is Euler's form. According to Euler's form, e power iota theta is nothing but cos theta plus iota sin theta. This is Euler's form, cos theta plus iota sin theta. This is your Euler's form. Okay. So if we will also raise it to the power n, so we will get e power iota n theta. So the final answer would be cos of n theta plus iota sin n theta. So this is what the De Moivre's theorem basically states. And the result can be shown true when n is a negative integer and even n is a rational number. मतलब this result holds true even in case of n being negative or n being a rational number. In each and every case, this result holds true. ठीक है. So इसको मैं बोलता हूँ Euler's form. This is Euler's form. This is your Euler's form. Okay. Now coming on to uses of De Moivre's theorem to find सबसे पहला use to find the roots of complex numbers. Let's say some complex number is given to me and I have written it in the form of r cos x plus iota sin x, where r will represent the modulus and tan theta या tan x is the angle. So similarly from there I got cos x plus iota sin x. So to get the nth roots of z, we will basically do power 1 by n of all these things. So we will get r power 1 by n into cos of x plus 2k pi upon n plus iota sin x plus 2k pi upon n, where k will go from 0 to n minus 1. So learn this formula. This is actually very important. If k is equal to 0, then we will simply get r power 1 by n cos of x by n plus iota sin x by n by applying De Moivre's theorem. यहाँ पे मैंने क्या लगाया? यहाँ पे मैंने लगाया De Moivre's theorem. ठीक है. So, and the rest roots I can calculate by putting the values of k as 1, 2, 3, and dash 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 up to n minus 1. Why up to n minus 1? Because one root is already 0 and we know that it has n roots. So one will be 0 so when we will count from 0 to n minus 1, total there are n roots. So this was one of the uses of De Moivre's theorem. Then secondly, to obtain relationships between powers of trigonometric functions and trigonometric angles. We use the polar form of complex numbers to represent a complex number using trigonometry, where let's say a is your r cos x and b is your r sin x. By this formula, a is your r cos x and b is r sin x. So r would be root of a square plus b square and tan x is b by a. From there, you will simply get your trigonometry angle, which is tan theta equal to b by a. Then this is also a concept of De Moivre's theorem only, raising to a power. So when we will evaluate 1 plus iota power 1000, so how do that? We have to basically use De Moivre's theorem here also. So how to use it? Firstly, whenever something raised to a power is given, try to convert it in the form of De Moivre, like r cos theta plus iota sin theta, where r is what? R is nothing but the modulus of the complex number, which would be here 1 square plus 1 square. 1 square plus 1 square. That would be equal to root 2. This is my r times cos of theta. Theta would be b by a 1 upon 1, that is equal to 1. So tan theta is 1 implies theta is equal to 45 degree. So root 2 times cos pi by 4, cos pi by 4 plus iota sin pi by 4, iota sin pi by 4. So you got root 2 times cos of pi by 4 plus iota sin pi by 4. So this is your, and then I will raise it to the power 1000. Raising it to the power 1000 would give me root 2 power thousands, and then cos of raised to the power 1000. We will get what? We will get root 2 power 1000, and then cos of 1000 pi by 4 plus iota sin 1000 pi by 4. Cos of 1000 pi by 4 plus iota sin iota sin 1000 pi by 4. Cool. And we know that 1000 upon 4 is nothing but 250. So it would be 250 pi. And cos of 250 pi is nothing but 1. So this thing is equal to 1. And this thing is equal to 0. So my final answer would be root 2 power 1000. Root 2 पावर 1000. ठीक है. सो इसको मैं चाहे 2 पावर 500 भी लिख सकता हूँ. ठीक है. So 2 power 500 is my final answer to this question. Now moving ahead, express 5/5 roots of root 3 plus iota in trigonometric form. So z is equal to a plus ib, and we will write in the form of cos theta plus iota sin theta, which is r cos x plus iota sin x, where tan x is b by a. Calculating r from here, it would be root 3 square, which would be 3, plus 1 square would be 1. So 3 plus 1, that would be 2 only. So r is equal to 2. So 2 times cos of theta, theta would be 1 upon root 3. Tan theta is 1 upon root 3. So tan theta is 1 upon root 3 implies theta is my 30 degrees. So cos 30 plus iota sin 30. And we need 5/5 roots of root 3 plus iota in trigonometric form. So as I just told you, for fifth roots of unity, we will get z equal to 2 power 1 by 5 cos of theta plus 2k pi upon n. Theta plus 2k pi, as I just told you, the de Moivre's formula, cos theta plus 2k pi upon n plus iota sin theta plus 2k pi upon n, theta plus 2k pi upon n, 2k pi अपॉन n. ठीक है. सो ये चीज मिलेगी मुझे. अब यहाँ पे मेरे को पता है कि k की वैल्यू कहाँ से कहाँ तक जाएगी. द वैल्यू ऑफ k विल रेंज फ्रॉम 0 to n minus 1, 0 to 1, then 2, up to n minus 1, up to dash 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 up to n minus 1. So I will get my z equal to 2 power 1 by 5 cos of theta is 30 degrees. So putting k equal to 0, I will get 30 upon n. N is my 5. So 30 upon 5 is 6 degrees. So cos 6 plus iota times sine of 6. This is my first root. Similarly, I will calculate my other roots by putting the values of k as 0, 1, 2, 3, 4. So similarly, I will calculate all the roots and I will get my final answer as these five roots. You have to just put the values of k, n is 5, n is fixed equal to 5, theta is equal to 30 degrees, and k value will range from 0 to 5, 0 to 4. From 0, 1, 2, 3, 4, you will get five different values of your z, and those five values of z will be your 5 fifth roots of root 3 plus iota. ठीक है. आगे चलते हैं. If 1 plus iota, 1 plus 2 iota, 1 plus 3 iota up to 1 plus n iota is equal to a plus ib, then what is the value of 2 into 5 into 10 up to 1 plus n square is equal to what? मतलब मुझसे इसकी वैल्यू पूछी है. And I've been given that this whole expression is equal to a plus iota b. This whole expression is equal to a plus iota b. ठीक है. So what will I do? If I will take conjugate both sides, basically taking conjugate, यहाँ पे मैं क्या कर रहा हूँ, यहाँ पे मैं दोनों तरफ conjugate ले रहा हूँ. Taking conjugate both sides. Conjugate both sides. Taking conjugate both sides would be something like this. Conjugate is distributable over your multiplication. So this is your conjugate. So from here you will get 1 minus iota, 1 minus 2 iota, 1 minus 3 iota, dash 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 up to 1 minus an iota equal to a minus iota b. So one equation is this and second is this. And you want something like this. So you have to just basically multiply both these two, because when you will multiply, you know, on multiplying you get something as a square plus b square. When you multiply a plus iota b with a minus iota b, when we multiply these two, we tend to get a square plus b square. We tend to get a square plus b square. So always, so 1 plus iota, 1 minus iota would give me root of 1 square plus 1 square, that is equal to 2. 1 square plus 2 square would be equal to 5. 1 square plus 3 square, that will be equal to 10. So multiplying all my terms on my LHS, I will get what is written on my LHS, and multiplying these two, I will get a square plus b square. So this thing is equal to nothing but a square plus b square. So this was the simple application of conjugate of complex numbers. Basically what we did in this question, we took conjugate on both sides of equation. So all terms got negative, 1 minus iota, 1 minus 2 iota, 1 minus 3 iota, dash 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 up to 1 minus an iota is equal to a minus iota b. Then I multiplied both the equations. On multiplying, I got 2 into 5 into 10 up to 1 plus n square, which I wanted, equal to a square plus b square. So a square plus b square is my final answer. Okay. Next question. If z is a complex number, then the minimum value of mod z plus mod of z minus 1 is equal to what? So here we will be using a triangle inequality. So what was triangle inequality? Let's say this is the triangle, and here let's say this is z1, this is z2, and this is z3. Then z1 plus z2 mod would be always less than equal to mod of z1 plus z2. So that property will be used here. Mod of minus z is equal to mod z, because mod will only give you the magnitude, and this is your triangle inequality. So mod z plus mod of z minus 1 would always be less than equal to, greater than equal to mod of a plus b, z1 plus z2, that is equal to z plus 1 minus z. So this thing is always greater than equal to 1. So minimum value of this thing is equal to 1. So basically what I did is I took mod z equal to z1. This thing is my z1 and this thing is my z2. So I did what? I took mod of z1 plus mod of z2 is less than equal to, sorry, greater than equal to mod of z1 plus z2. But I know that mod of z2 is equal to mod of minus z2, so I replace it with negative. So this thing will also be true. So mod of z plus mod of z minus 1, yeah, mod of 1 minus z is equal to, is greater than equal to z plus z plus negative of z minus 1 would be 1 minus z. So z and minus z would cancel and you will get 1. So mod of z1, that is z, plus mod of minus z2, which would be z minus 1 only. Mod of z plus mod of z minus 1 would be greater than equal to 1. And since minimum value is being asked, so 1 is your final answer. Just remember this inequality. And you can also remember one more thing. This thing is always less than mod of, greater than mod of z1 minus z2. So this is the ultimate theorem. Mod of z1 minus z2 is less than equal to mod of z1 plus z2, which is further less than mod z1 plus mod z2. Oof. For any two complex numbers z1 and z2 and any real numbers a and b, this expression equates to what? So basically, this is something like mod z square, and mod z square is nothing but z into z bar. This is a property of complex numbers. Please remember it. When we multiply a complex number by its conjugate, we get mod of z square. As I already told you, a plus iota b into a minus iota b is a square plus b square, which is nothing but the square of the modulus of complex number z. So mod z square is equal to z into z bar. So here z is equal to a z1 minus b z2. So a z1 minus b z2 multiplied by its conjugate. Conjugate is nothing but a z1 bar minus b z2 bar. Similarly with this expression, bz1 plus az2 into bz1 bar plus az2 bar. Az2 bar. Now just multiply both these two equations. You will get ab. Yeah, it would be a square and b square into mod of z1 square plus mod of z2 square, because again z1 into z1 bar is equal to mod z1 square, and similarly z2 into z2 bar is equal to z2 square. So from there you can calculate this expression. Just this is squared. So this was question number 3. Find the complex number z satisfying the equations, these two equations. मेरे को दो equation दी गई है, and now we have been asked to find the value of z which will satisfy both these two equations. So equations are mod of z minus 12 upon z minus 8 iota equal to 5 by 3, and mod of z minus 4 upon z minus 8 equal to 1. So there are two equations and we have to calculate the value of z by using these two equations. So for solving this thing, keep z equal to x plus iota y, z equal to x plus iota y. So from here what you will get, you will be getting mod of x minus 12 plus iota y multiplied by 3 is equal to 5 times mod of x plus y minus 8 iota. Now square both sides. You will be getting 9 times x minus 12 square plus y square equal to 25 times x square plus y minus 8 whole square. Just remember mod z square is equal to a square plus b square, because whenever you multiply a complex number by its conjugate, the imaginary term vanishes and only real part remains, and the value of real part is nothing but the sum of squares of real and imaginary parts. So this is one equation, and similarly we will get the second equation by solving for z minus 4 upon z minus 8. So here also put z equal to x plus iota y. So you will get x minus 4 plus iota y is equal to mod of x minus 8 plus iota y. And then again square both the sides. Squaring both the sides, you will get x minus 4 square plus y square equal to x minus 8 square plus y square. And then two equation, two variable, you can solve for x and y. So you will get x equal to 6 and y equal to 17 and 17 or 8. So y equal to 17 or 8, that's why both the solutions are correct. That is, you will get the final z to be equal to either 6 plus 8 iota or z is equal to 6 plus 17 iota. Both the answers are correct. You have to just solve for these two equations. Two equation, two variable can be easily solved, and then you can calculate the value of x and y. When you calculate the value of x, you will get it to be equal to 6. Then put the value of x in any of the equations, you will get the value of y. Because since you are getting a quadratic equation and quadratic equation has two roots, so you are getting two values for y, 17 and 8. So both are your correct answers. One is 6 plus 8 iota, another is 6 plus 17 iota. So this was your question number 4. Okay, now moving on to question number 5. Here it is given z1 is equal to 10 plus 6 iota and z2 is equal to 4 plus 6 iota, and z is a complex number such that this thing is satisfied. Amplitude of z minus z1 upon z minus z2 is equal to pi by 4. Amplitude is nothing but theta, which is, you say na, tan theta is equal to a by b. So this theta is nothing but the amplitude. So tan theta equal to a by b. Let's say this is your Argand plane. And in Argand plane, the this axis is your this y-axis is your imaginary axis, and x-axis is real axis. So if you will plot any complex number, let's say here x plus iota y. So this theta is nothing but amplitude of your complex number. So tan theta is equal to a by b, or in this case, it is equal to y by x. So you have been given this equation that amplitude of z minus z1 upon z minus z2 is equal to pi by 4. Then you have to calculate the value of this expression. So how to do it? Firstly, again, put x equal to z equal to x plus iota y, general derivation for z. So z is equal to x plus iota y. From there, and z1 and z2 values are given to you. Z1 is equal to 10 plus 6 iota, and z2 is equal to 4 plus 6 iota. So put both the values, and you will get this thing, x minus 10 upon plus iota times y minus 6, x minus 4 plus iota times y minus 6. Obviously, here it would be division sign. So now how to calculate amplitude? You know that amplitude, since amplitude is pi by 4, so you know that tan pi by 4 is equal to 1. Tan of pi by 4 is equal to 1. So from here you got this equation, x minus 4 y minus 6 minus y minus 6 x minus 10 upon this thing is equal to 1, and then you finally got this equation. Now they are asking you to calculate the value of z minus 7 minus 9 iota, and the mod of this thing is equal to, again put z equal to z is equal to x plus iota y, so it would be mod of x minus 7 plus iota times mod of y minus 9. But the for calculating mod you have to square it, because we know that mod square is nothing but real square plus imaginary square. And in this case real part is x minus 7 and imaginary part is y minus 9. So x minus 7 square plus y minus 9 square is equal to 18, and from there you can get the value of your expression, which would be 3 root 2. So you have to just know the basic definition of amplitude. Amplitude just represents the angle, which is your tan theta. Tan theta equal to y by x. So Z1 was given to you, Z2 was given to you. You just calculate the amplitude. Amplitude was given to us pi by 4. So tan pi by 4 equal to 1. From there you got this equation. And so you got this equation as this thing. And you know that this value is equal to 18. How you know that this is equal to 18? From this equation. When you will open this equation, you will get x square minus 14x, x square minus 14x plus 49. So add 9 here. Basically, x square minus 14x plus 49 plus y square minus 18y plus 81 equal to 18. This equation is nothing but this one. This equation is same as this one. So from there, now you know that this is nothing but x minus 7 square and this is nothing but y minus 9 square. So from there, you got it equal to 18, but you just need to calculate the value of mod of this thing. So you will take under root of 18, and root of 18 is nothing but 3 root 2. So 3 root 2 is your final answer. Okay. Moving on to next one. Suppose Z1, Z2, Z3 are the vertices of an equilateral triangle. So a triangle is given to you, and they are saying that these three vertices are Z1, Z2, and Z3. And this is inscribed in a circle of radius 2, mod Z equal to 2. So this thing is your circle, and this radius is equal to 2. Mod z equal to 2 represents a circle where the value of mod z is the value of radius only. Since if this is your argand plane, then mod z equal to 2 is nothing but something like this. Well, this distance is equal to this distance is equal to this distance is equal to this one, and this is equal to radius, which is equal to mod z. So this equilateral triangle is inscribed inside the circle of mod z equal to 2, and z1 is given to you as this. मतलब मेरे को एक coordinate दिया हुआ है. This is 1 plus iota root 3. Iota root 3. So this is my z1, and then I have to calculate the values of z2 and z3. So I know that if I will calculate the value of one of z1, one of z2 or z3, then second value can be easily calculated. But how to do this thing? Since first thing it is given to me that this is my equilateral triangle. So this angle is 60 degrees, and this angle is also 60 degrees. And z1 is equal to 1 plus root 3 iota. So if I will take the symmetry, if I will draw it correctly, it is something like this. This is my circle, and this is my triangle. So basically this point and this point are nothing but complex conjugates of each other. That is, if one is a plus iota b, second is a minus iota b, because it is drawn something like that only. So if one is a plus iota b, then second would be its conjugate. So if one is 1 plus iota root 3, second would be 1 minus iota root 3, and third would be, third I will get by multiplying it by 2 pi by 3. Basically, in a triangle whose circle is at 0, 0, this thing is z1, and I know that this angle is 120 degrees. So I will get z2 by multiplying z1 by e power iota into 2 pi by 3. I will get this and I will get z2, and then by multiplying z2 by again e power iota 2 pi by 3, I will get z3. This is also 120. So z2 is equal to z1 times e power iota into 2 pi by 3, and z3 is equal to z2 into e power iota 2 pi by 3. So this e power iota into theta, this is known as the rotation complex number. E power iota theta is the rotation complex number. Whenever you want to rotate a complex number by some angle theta, then the value of new complex number would be nothing but the old complex number multiplied by e power iota theta. And theta is the angle by which you want to rotate your complex number. So if you know one complex number, then you can easily calculate the other two by simply multiplying it by e power iota theta. So since this is on mod z equal to 2, so this is also equal to 2, this is also equal to 2. This was given to me just to tell me that the length of this thing is same in each of the three cases. So I have to just rotate the complex number by 120 degrees in each case. So if z1 is equal to this, then z2 is equal to this thing multiplied by e power iota 2 pi by 3. E power iota 2 pi by 3 is nothing but cos 2 pi by 3 plus iota times sine 2 pi by 3, sine 2 pi by 3, and cos 120 is, this is the graph for my cos. So this is 90 and this is 120. Cos 120 is minus half. So minus half plus sine 120 is, this is my 90 and this is my 120. Sine 120 is root 3 by 2 plus root 3 by 2 iota. So you have to multiply this one with 1 plus iota root 3. On multiplying, you will get what? Minus half. This iota and this iota will form minus 1. So minus 3 by 2. Multiplying root 3 and root 3 will give me 3, and iota into iota is minus 1. And then plus iota times minus root 3 by 2 plus root 3 by 2, that is equal to 0. So this is giving me minus half and minus 3 by 2, that is equal to minus 2. So 1 is my minus 2, which is given here. And then when I will multiply minus 2 by e power iota 2 pi by 3 again, I will get 1 minus iota 3. So basically, if I will redraw the diagram is something like, this. This is my circle. Minus 2 is somewhat here. So this is my diagram. This point is my given point, which is 1 plus iota root 3, 1 plus iota root 3. This point is my 1 minus iota root 3, and this point is my minus 2. So you can either multiply each complex number by e power iota 120 degrees, or you can just need to multiply once, and the second can be easily taken by taking the conjugate of this thing. So this is what they have did here. Z1 is given to you. When you took the conjugate of Z1, you got Z3, and Z2 is calculated by multiplying it by e power iota 2 pi by 3 or e power iota minus 2 pi by 3. माइनस किस केस में करेंगे? अगर मैं ये वाला ले रहा हूँ इनिशियली, then I am basically turning in clockwise direction. So when I always try to turn clockwise, I take negative sign, and when I turn anti-clockwise, then I will take positive sign. From this 1 plus iota root 3, if I need to go to minus 2, I need to turn anti-clockwise. So minus 2 is either equal to 1 plus iota root 3 into e power iota 2 pi by 3, or 1 minus iota root 3 into e power minus iota 2 pi by 3. In case of clockwise, you will take theta to be negative, and in case of anti-clockwise, you will take theta to be positive. So theta is positive in anti-clockwise rotation, and theta is negative in clockwise rotation. Okay. I'm moving on to next one. If the cube roots of unity are 1 omega omega square, then find the roots of equation this one. मेरे को cube roots of unity दी गई है. Cube roots of unity means x cube equal to 1. X cube equal to 1. So what all values of x will satisfy this one? X equal to 1 will satisfy, x equal to omega will satisfy, and x equal to omega square will satisfy. Here omega is equal to half plus iota root 3 by 2. And omega square is omega square is minus half minus iota root 3 by 2. Basically, omega and omega square are complex conjugate of each other. Are complex conjugate of each other. So from here, now I've been given the solution for x cube equal to 1, and the solution for x minus 1 cube equal to minus 8 is asked to me. So x minus 1 cube is equal to minus 8. From there, I will get x minus 1 equal to minus 8 power 1 by 3. So basically, this thing is equal to 2 times minus 1 power 1 by 3. Okay. So basically, x minus 1 is equal to minus 1 power 1 by 3 into 2. And minus 1 power 1 by 3, you can easily write it as minus 1 comma minus omega and minus omega square, because cube roots of unity is 1 omega omega square, and cube roots of minus 1 are minus 1 minus omega and minus omega square, multiply by 2. So basically x minus 1 के जो roots होंगे, that would be minus 2 omega and minus 2 omega square. So यहाँ से मैं x के roots निकाल सकता हूँ. I will take minus 1 that side. So I will get x equal to minus 1 minus 2 omega plus 1 and minus 2 omega square plus 1. Just remember one thing, that the roots of unity are 1 omega and omega square, and roots of negative of unity is minus 1 minus omega and minus omega square. You have to just multiply it by 2. So you got the roots for x minus 1. Then since the roots of this equation is asked to you, so means the value of x is being asked. So to calculate the value of x, add 1 to each term. So you will get minus 1 minus 2 omega plus 1 and minus 2 omega square plus 1 as your final answer. So these three are the roots of your given equation. Moving on to question number 7th. If cos alpha plus cos beta plus cos gamma is equal to sin alpha plus sin beta plus sin gamma equal to 0. So two expressions are given to you and they are saying that the value of these two expressions is equal to 0. Then what is the value of cos of 3 alpha plus cos of 3 beta plus cos of 3 gamma? Basically trigonometry का question है, but since we are doing it in complex numbers, so we have to just use some of the concepts of it so that it can be simplified. This can also be done by using trigonometry, by using triple angle formulas of sine and cos, but this would be easier if you do it by complex numbers. So these two equations are given to you, either cos alpha plus cos beta plus cos gamma equals to 0 and sin alpha plus sin beta plus sin gamma equal to 0. So how to convert it in complex number? Hmm. We know that De Moivre's theorem says that a complex number can be written in trigonometric form using cos theta plus iota sin theta. Cos theta plus iota sin theta. And you have to multiply it by the given by its modulus, that is equal to r. So just let three complex numbers. First is cos alpha plus iota sin alpha. Second is cos beta plus iota sin beta. Third is cos gamma plus iota sin gamma. So let first complex number be equal to a, second be equal to b, and third be equal to c. And now add all these three complex numbers. On adding, you will get cos alpha plus cos beta plus cos gamma plus iota times sin alpha plus sin beta plus sin gamma. And since this thing is equal to a plus b plus c, and since these two expressions are given to be equal to 0, so this thing is equal to 0. So basically, cos alpha plus cos beta plus cos gamma plus iota times sin alpha plus sin beta plus sin gamma is equal to 0. So this is something like a plus b plus c equal to 0. And we have studied that a plus b plus c equal to 0 implies a cube plus b cube plus c cube is equal to 3abc. ये चीज़ हम लोग नाइन्थ में पढ़ते हैं अलजेब्रा में कि जब a प्लस बी प्लस सी जीरो होता है तब a क्यूब प्लस बी क्यूब प्लस सी क्यूब की वैल्यू 3abc के बराबर होती है. Why so? Because when you will take the cube of a plus b plus c, you will get a cube plus b cube plus c cube minus 3abc times a plus b plus c. So a plus b plus c is equal to 0. So this thing is equal to a cube plus b cube plus c cube is equal to 3abc. So take the cube of all the three complex numbers. Cube of cos alpha plus iota sin alpha, cube of cos beta plus iota sin beta, cube of cos gamma plus iota sin gamma, and this thing is equal to 3 times cos of alpha plus iota sin alpha, beta, and gamma. So cube root is, you can calculate this cube this power raised to the power 3, this complex number raised to the power 3 by using De Moivre's theorem, which states that if any complex number is raised to some power, then the answer would be cos of n alpha plus iota sin n alpha. So here n is equal to 3. So cos 3 alpha plus iota sin 3 alpha plus cos 3 beta plus iota sin 3 beta plus cos 3 gamma plus iota sin 3 gamma. This is from De Moivre's theorem. सो यहाँ से हमको ये चीज मिली और जो मेरे को पूछा गया था वो भी 3 अल्फा 3 बीटा 3 गामा ही पूछा गया था. सो वी आर हेडिंग टुवर्ड्स राइट डायरेक्शन. अब बस अपने को ये चीज और कैलकुलेट करनी है 3abc की वैल्यू क्या होगी. सो 3 cos alpha plus iota sin alpha, सिमिलरली फॉर बीटा एंड सिमिलरली फॉर गामा. सो यहाँ से मैं क्या कर सकता हूँ, आई कैन टेक 3 कॉमन एंड आई विल गेट cos alpha plus beta plus gamma plus iota sin alpha plus beta plus gamma. So this thing is equal to cos 3 alpha plus cos 3 beta plus cos 3 gamma. So you can calculate the value of this thing to be equal to 3 times cos of alpha plus beta plus gamma. ठीक है। तो बस में ये वाला एक्सप्रेशन यूज करना है, a क्यू प्लस b क्यू प्लस c क्यूब इक्वल टू 3abc वाला। ये तभी क्लिक होगा और ये चीज आपको दिखेगा कि आप जब तीनों को लोगे और तीनों को ऐड करोगे तब ये चीज जीरो आ रही होगी। तो वहां से आप ये चीज देखोगे कि a क्यू प्लस b क्यू प्लस c क्यूब 3abc के बराबर है। इसका क्यूब आप निकाल लोगे डी मार्गन थ्योरम से। सो कॉस 3 अल्फा प्लस आयोटा साइन 3 अल्फा। सिमिलरली इसका भी निकाल लोगे, सिमिलरली इसका भी निकाल लोगे। सो यहाँ से आ गया मेरा क्यूब वाले टर्म्स। और ये है मेरा 3abc वाला टर्म, 3 टाइम्स कॉस अल्फा प्लस आयोटा साइन अल्फा, कॉस बीटा प्लस आयोटा साइन बीटा एंड कॉस गामा प्लस आयोटा साइन गामा। फिर इसको मैंने क्लब कर दिया ऐसे करके, एंड आफ्टर क्लबिंग आई गॉट माई फाइनल आंसर जो मुझसे पूछा गया था। सो माई फाइनल आंसर इज 3 टाइम्स कॉस ऑफ अल्फा प्लस बीटा प्लस गामा, बिकॉज दे हैव आस्क्ड मी द रियल पार्ट ओनली, एंड सो रियल पार्ट इज माई this thing is imaginary part. This thing is equal to sine 3 alpha plus sine 3 beta plus sine 3 gamma. But since only cos 3 alpha plus cos 3 beta plus cos 3 gamma is asked to me, so my final answer is 3 times cos of alpha plus beta plus gamma. Moving on to question number 9. If 1 omega, omega square, omega cube, and omega power n minus 1, these are the nth roots of unity, then the value of this thing is equal to what? So again, इसमें ये वाली एक आइडेंटिटी होती है जो हम लोग पढ़ते हैं क्यूब रूट ऑफ यूनिटी में, कि जब मैं x-1 x-ओमेगा अप टू x-ओमेगा पावर n-1 करता हूँ, सो आई विल गेट दिस थिंग, एंड दिस थिंग इज नथिंग बट z पावर n इक्वल टू 1 प्लस z-1 z-ओमेगा z-ओमेगा स्क्वायर। दिस इज माई आइडेंटिटी विच आई रीड इन कॉम्प्लेक्स नंबर्स। तो इसको अगर नहीं पता तो ध्यान रख लेना, इसको चाहे ऐसे भी ध्यान रख सकते हो कि z पावर n-1 इसके बराबर होता है। सो ये वाली मेरी आइडेंटिटी है, इसमें मैंने कहीं भी अपना दिमाग नहीं लगाया। ये सिंपल मेरी आइडेंटिटी थी। अब इस आइडेंटिटी में अगर मैं x की जगह 1 डाल दूंगा तो मेरे को ये वाला एक्सप्रेशन मिल जाएगा। तो मैंने यहाँ पे x की जगह 1 डाल दिया। तो जब मैं यहाँ पे x की जगह 1 डालूंगा तो मुझको क्या मिल जाएगा? बेसिकली मुझको मिल जाएगा, मुझसे सिर्फ इतना ही पूछा है ना। अच्छा, मुझसे मैं गया हूँ ओमेगा से लेके ओमेगा पावर n-1 तक, मतलब मैं यहाँ से स्टार्ट करके यहाँ तक गया हूँ। तो मैं x-1 को उधर ले जाऊंगा। सो बेसिकली मेरे को ये वाला एक्सप्रेशन मिल जाएगा, एंड दिस थिंग इज इक्वल टू x पावर n-1 अपॉन x-1। ठीक है। अभी मैं क्या कर सकता हूँ? मेरे को पता है कि x पावर n-1 अपॉन x-1 इसके बराबर होता है 1 प्लस x स्क्वायर प्लस एक्स क्यूब, मतलब ये चीज होती है ना एक्स क्यूब। अगर मैं एक्स की n की जगह 3 लूंगा तो मेरे को पता है कि x³ - 1 अपॉन x-1 इज इक्वल टू 1 प्लस x ऐसे होता है ना ये आइडेंटिटी हम लोग पढ़ते हैं ना कि मैं किसी का भी क्यूब करूं। लेट्स से मैं x पावर n-1 लिख रहा हूँ, तो इसकी वैल्यू क्या होती है? इसकी वैल्यू होती है x-1 मल्टीप्लाइड बाई 1 प्लस x स्क्वायर अप टू x पावर n-1। सो अप टू x पावर n-1। तो वही चीज मैं यहाँ पे यूज करूंगा। सो यहाँ से मुझे मिल जाएगा 1 से लेके x पावर n-1 तक, एंड नाउ आई विल पुट द वैल्यू ऑफ x इक्वल टू 1। सो दिस थिंग वुड बी इक्वल टू 1 प्लस 1 कितने टाइम्स ये आएगा? n-1 टाइम्स। सो 1 प्लस 1 प्लस 1, एक 1 ऑलरेडी है तो टोटल n टाइम्स हो जाएगा। सो 1 आएगा n टाइम्स एडिशन में। सो मेरा फाइनल आंसर हो जाएगा n×1 दैट इज इक्वल टू n। सो दिस इम्प्लाइज इस वाले एक्सप्रेशन का जो फाइनल आंसर आएगा वो आएगा n। सो लेकिन इस क्वेश्चन को सॉल्व करने के लिए मेरे को ये वाली आइडेंटिटी आनी चाहिए कि z पावर n इज इक्वल टू z पावर n-1 इज इक्वल टू z-1 z-ओमेगा अप टू z पावर ओमेगा n-1। अगर ये वाली आइडेंटिटी नहीं पता तो फिर ये वाला क्वेश्चन सॉल्व करना बहुत डिफिकल्ट होगा। ठीक है। So this was all about my complex numbers. Just remember these two theorems. One is De Moivre's theorem and other is this triangle inequality. These are the two important applications of complex theorem which are many a times asked in JEE Mains paper. ये इसको बोलते हैं triangle inequality and this is known as my De Moivre's theorem. इन दोनों चीज को याद रखना from these two and the concept of uh, cube root of unity. These three concepts are mainly asked in JEE Mains. So please revise these three concepts and rest is okay. So okay, and next, uh, all the other questions we will doing in our next session. So thank you.